Hey guys, it is I, and today we are going to be binding multidict to Cython, and I'm about to finish the CAPI, but the reason why I am going to be trying to get multidict into Cython, and why I'm going to try and make everything today Cython compatible. Make sure I'm recording. Reason why I'm trying to make everything Cython compatible is because it is being utilized in Cython for the HTTP parser. And it would make more sense if multidict could be made into a Cython module so that these pieces could theoretically run faster. So with that out of the way, I will kind of show what I've done so far. I added in this portion. Luckily, everything was pretty easy to find, but most importantly, you have to remember to find anything that's not a vector call. Like, as you can see right here with MD pop 1, it's a vector call because of this signature. You want to avoid anything with this signature if you're going to bind to other sources. So it made sense to bind this one instead as well because it has a better system, and because I can use an integer to check to see if we failed. So that felt pretty important to me to add that in. But now that we've sort of like binded everything, the reason why I didn't need to like bind types is because, well, it's already going to have them at runtime. So it wouldn't really make much sense to add them here. Hence why I didn't do that. I've had multiple rewrites of this thing, but I feel like I've got it down to the point where I figured out and sort of memorized everything. And I did make sure that I have comments right here to the functions that I was binding to. Know that these comments might be gotten rid of in the whenever this is updated, but I believe these should stay, mainly in case users are trying to figure out where these are all being mapped to. But if you need more information on how the Python C API works, I recommend reading this documentation. This is what I've been using. And because sometimes people will try and send things to C++, I've done that as well. But now, with everything out of the way, we can actually sort of get started. You will see I've sort of underlined all of these functions, and that is because I am planning to rig these up with macros here in a little bit, so that we don't have to call the API thingy directly, and instead we'll be able to just call it from a macro. So let me go ahead and write down those macros. The other thing I'm going to point out is that we don't need some of the other like subclasses and whatnot, because I can bind those directly with Cython. And you'll see that, I guess this is a little preview, but I found a clean reference that we can use if we ever get stuck. We can just look at this to figure out and solve our problems. Anyways, I'm going to go off camera, put down these macros really quickly, and then when I come back, we'll start with the next pieces. So I did make some stuff in a little over an hour. And currently, what I've done is I have tried to merge the case insensitive multi-dicts to the same object, because in all reality, in the code, they are literally just this. Except the only thing that has changed with the type is that there's a flag that's set to say that this is case insensitive, which is short for I could be lowercase and uppercase, but I still am the same key. But the only tricky part now is going to be to bind all this. Something you can do, and I'm glad that I wrote this like this, is that these mean the exact same thing. It's just that if you want to interact with this and get it to compile, you're going to want to, well, get rid of any like structure type objects, since they are already mapped if you already have done so. In my case, I have chosen to ignore the size of the object because these can allocate dynamically and be freed dynamically as well. So pretty important to note that I chose to ignore the size of them. And in this example right here, I have mapped the object, if I can show it. I have mapped this object for the proxy object, which, if I remember correctly, the proxy object does not allow mutation to occur. But anyways, that being said, I'm going to finish mapping this here in a bit. And I'll skip over to that. But most importantly, I did wrap in an import, which is literally just same way date type is written, where I tell it to send in the capsule, and then from there I can map all these macros so that the API can be used. And here's where the date time source code is, and I'm using this as reference for helping me write everything down. But it's very useful to have a resource for when you want to figure something out, which is why I also have datetime.h on hand as well to help me. It probably was a cleaner reference than NumPy was, but NumPy did teach me some important stuff about type aliasing, which is what I've got going on here, where this and this mean the same thing, but they can be mapped to this object and still be defined the same. And in my case, I have mapped the C module. When compiled, it will import this object, and that's how I'm mapping everything, which is why I don't have a PYX file, because I don't think we'll need one. The only one I really think we will have to just inline is just this, since this is how the Get API is working under the hood. And basically what I did is that if you want to pass null right here, it'll return as none. But anyways, that's all I've really got for right now. I'll probably try and put in some inline methods into multi-dict. So like, for example, if I were to say, I'm going to make some inline methods really fast. So like if I were to say like get all, for instance, create a list. I'm going to call it get all, just like in the normal API. I'm going to now say that if the object is null, I'm going to have it throw a key error, and I'm going to say which key it was. So if I do multidict get all, and I could pass self, I could pass the key, and then I'll pass the return object. I've already got it externed, and then I also have this, which I wanted to share that if you're going to interact with something in C, it's normally going to be faster if the object can be returned as a C object. And if the object's being returned as a C object, it's going to be much faster to throw the error as if you're going to run it in C Python. That is actually a change I recently made to frozen list, or the one I'm trying to add, just where I throw the error in C API fashion, and then I return like -1. So like, here's a really good example of what I'm trying to refer to, which is that if I can't, or if something fails and I want to throw an error, I can just run it this way if it's in C. If it's in Python, you can just raise the error normally. It's not cpdef or cdef, and it's not returning a Python object. But in this case, I do have it set to return a Python object, so I am going to have to do some stuff for that real quick. I'm going to tie a ref to right there, and then if get all is less than 0, that means there was an error. And I'm going to put down, I'm going to raise that key error. But like I said, if this were returning, if I were returning something completely different like care, here's what I'm going to do. I would use the C Python API key error and then key, and then I would return null. So hopefully you understand that now, and why I choose to do that on CDEF versus Python defined functions in Cython. But anyways, enough explained. I'm going to go back to returning a list. I'm going to raise that key error with that key, and then if all goes well, then this should return something. Now, I'm gonna have to. Another thing you can do too, which is pretty useful, is that you can go through the C source code that you're trying to use. Sometimes you will be able to optimize stuff, and I have done so in the past with some of my projects. But what I'm checking for to see is if return uses an ncref by default. Because if it does, then I won't have to do anything with it. But it looks like I'm going to have to use an ncref. If you don't know what an ncref is, it's Python's version of reference counting. Which is going to be this. But in my case, I want to hook this directly to a Python object. So what I'm actually going to do is I'm going to cheat a little bit. This is something you can do if you want to just run with this Python objects thing that I've imported is that I can extern this, and then this is going to be a void. I'm going to get rid of that. And there we go. It'll run like normal because it's a macro, and macros don't normally care, although Cython will care if I don't map my types correctly. It's just that there are little things you can do to cheat the system to make everything work. But now I can reference this return object, and then I will map that to a list and return that. And then there we go, problem solved. On to the next one. If I were to c-define, if we were to c-define these in without the inline, it will not compile because we're in a pxd file. If we were in a pyx file and we weren't externing anything, we would be able to get away with not having to use inline. But in my case, I have to, because I want to just use a pxd file for this pull request I'm making. But anything can be changed, and this source code may not look the exact same way when it's done. So that's probably something safe that I need to point out. And then here's our default. And remember not to worry if something is not like completely detected or is not defined. It's because of this triggering. It's because I have all of these defined down here because I need the extension defined. But now that I've done that, now that I've said enough, we can continue. And this goes for any C library. You should always check to see what it returns so that you're not having to predict anything. So if I were to look over at this source code right here for get1, we will see that we are going to need to store the return value, like as you can see over here. In fact, let me try something. We actually might be able to get away with a few things. I'm alright with copying this right now. I'm sure the other contributors will probably edit my stuff out if it's not agreed upon. And then I did say I want to do in cref. So that's what I'm going to do right here. Name that to RET because it's a return value, not a reference. And then there we go. There's another one for you. But in my case, we might not even need this. Hold on. I'm going to think about this a little bit because this is not, I'm not referencing a py object this time. Wait, it might actually be faster to reference this as a py object because you never know if someone wants to pass null to it. And there we go. So then get1 can be used in two different ways. It's either with the null or not. If I am correct, Cython will remember to do so. If not, I will have to make some adjustments. So now we're going to call get. Use that key. No, it's funny. I think these are the exact same thing. Weird. Okay, cool. Now on to my next one. And I'll do some of these, and then I'll probably skip to where I filled everything out, and then I'll probably teach how to compile. Because one of the most annoying things with Cython is actually compiling. You think your code probably is okay. Compiling is a different story. It has always been hell. Well, at least for me. But yeah, I'm gonna. These ones should be pretty easy, actually. It's gonna be an iterable, anyways. But I think it's okay, safe to call it an object because it's actually returning a view of how these pieces work. Now, maybe in the future we could theoretically add the different view objects from right here. But for right now, I'll do with what I've got. And maybe if a contributor actually wants these, we'll write them in. That's what I'm thinking. I'm going to continue with this. So in this example right here, we probably are only going to need keys. That's not a function. And then let me just fill out the rest of these because this can be pretty annoying. Because they're all just like one single method. You should never overburden yourself. Always take the easy route with something like this. Even I sometimes forget not to overburden myself. I think we could get away with doing that. And then here comes an object, key, and another object for a value. So the reason why I'm turning these into C methods like this, if you saw me just going through all these, is because Cython will remember to map these correctly to not using the Python calls, but instead using the C calls. Because we could already do this all in Python just fine. But when it comes to enabling speed, you might want something like this instead. And defining something as inline will ensure that what gets compiled is actually going to be like this, this. Like this is how it will basically like appear if you were to reverse engineer it in assembly. So now, guess we've done most of these. I'll probably skip ahead, but I would understand now that you understand the pattern of what's going on here. So I'm going to fill the rest of these out. And I'll probably make a little hack for running these with CI multi-dict as well, so that we do not have to try anything crazy. So I did want to finalize the video for right now. I probably won't get to compiling, but the only thing we really have to do is just get the include in there, which is what I figured out. And then it'll compile like normal. But I guess now we'll just have to remember to tell whoever's contributing to multi-dict that we need to keep all these header files. But luckily, we only have to include the wherever multi-dict is, because that's how I set this up. And if we look at everything, I lied to you, by the way. We don't really need anything for right here. It's probably a good thing, though, that I taught you that you could, you know, end up making inline methods in a PXD file. But we did keep this one, and I did add it in cref right here, probably off camera. But yeah. Anyways, that is going to be it. I will make that pull request very soon. I'll probably add in the proxy API, which will probably be pretty lazy, like I did with up here, except I'll have to just remember to point to everything, because the proxy is basically the child of the proxy dict is going to be the multi-dict object. But anyways, that is it. And as you can see over here is the NumPy version. I think my version's cleaner, but like I said, a maintainer might change this, or might ask me to change it. But anyways, that is it. I'm done now. I'll go get this pull request done, and I will see you all in the next video.